This video should augment the earlier one that I did on the full problem that was given in the chapter 3 of Jacobs, regarding a base case. Okay, so we're in the center of doing base cases here, just to know where we are. Okay, there's three concepts that I think we have to review that I'm going to put into this video to help us get through. These are the more fundamentals about what happened in that problem, so more people can follow it. It's really important that we get through this, because you can use this whether you have your own business, whether you're working for someone else, evaluating getting into a new project, whether it's going to make more money versus another project, or how inflation might affect it, or how much the borrowing rate might affect the profitability of your project. So again, we're doing the base case, chapter 3. The first thing we want to talk about is exponents. The next thing we're going to want to talk about is finance. And in the mix here, we're going to talk about some Excel solutions, how you do these things in Excel, okay, convert it over to Excel. So this should augment the other video. If you watch this, then more of the other video should make sense, or I should say all of the other videos should make sense. And then I'll create a separate video that just tees up, lines up the problem that we had, objective question number 10 at the back of the chapter there, which is very similar to the first base case, but actually asks us two more questions. Basically, we're going to mimic what happens in the example base case in the chapter, but then we're going to take a look at sensitivity analysis, which is covered in the chapter. That's what the parts B and C of the problem talk about. So we're going to cover these three things here first. I want to do a quick review of exponents here. Anytime you take a number, x, and raise it to another number, y, this is called the base, and this is called the exponent. Okay, so that's what we're talking about as far as exponents go. So we want to remember a couple behaviors here, how these things work, that can be helpful. So we're doing a simple case here. If anything number raised to the first power is going to equal itself. Okay, it's just you want to remember a little bit about these special cases here. X squared is just x times x. X cubed is a representation of this, of course. This is what it's all about. Okay, but this condition here, you just want to remember that when it's raised to the first, it's itself. Okay, now we can also have x raised to the 0, which is just 1. Anything raised to 0, anything raised to 0 is equal to 1. Can we have negative exponents here like this? Yes. How do we interpret those? This is a nomenclature that we use to show this. X to the minus 1 is 1 over x. X to the minus 2 is 1 over x squared. So when you see the negative number, it can also be shown a different way. It can be the number, just a number 1 over x squared. Does the exponent need to be an integer? Does it always have to be an integer? No. We can have x to the 1/2. And how do we interpret that? X to the 1/2 is the square root of x. X to the 1/3 is equal to the cube root of x. Okay, that's what those mean. We're not going to really use these here, but everything else we will up here. This ends up in finance. So let's go to Excel and show how some of these are used, just to make sure we're able to use Excel to make these calculations. Okay, so the first calculation we will do is just take some number and raise it to itself. We'll actually do it in here. So there's a couple different ways you want to be able to do this. Why I'm explaining this is that, okay, so there's an easy way to do it. And you say you want to take, let's use just the number 10 here. Okay, so the number 10, okay, and we want to multiply it by itself. The most basic way to do that would be 10 times 10 is equal to 100. Okay, well, a better way to do it would be use the exponents in Excel here. So you're going to take 10, use the caret symbol to raise it to some power of 2, 10 times 10, and you get 100. Okay, the next little example that we'll have here is 10 raised to the first power. Okay, we'll just see that that really worked. 10 to the first actually works, calculates out the same way. What if we take 10 raised to the 0th power? Great, it works. Okay, so the things that we just showed over here, I just showed how to do it in Excel. Okay, so we did a couple things. We did a positive number, we did 1, we did 0. Okay, so now let's take a look at using a negative exponent in here. So let's take 10 raised to the -1. Just put in -1 there, and lo and behold, 1 over 10 is 1/10 or 0.1. Okay, so that works. Okay, so that part works there just great. The last part to just show how to do in Excel is you have x to the 1/2, and so we would say 10 raised to the, and I'm going to put it in 1 over 2 like this. Use those parens, and the square root of 10 is 3 point, etc., etc. Okay, 10 raised to some number here. Well, we can also do this another way. We're going to repeat this, but we're going to use 10 raised to the 0.5. And look at that. So we've expressed it two different ways here. You can actually type this in different ways. Just to get ready for what we're going to see later on that happens in our Excel file for the problems of chapter 3. We want to use a cell reference. We want to use some cell references here. Let's say that the exponent that we want to raise to is 2, and then we just want to say raised 10 to the power of this. So we just click the cell there with the exponent in it, and it still works. 10 raised to 2. You can use a cell reference in there. So just keep in mind that you can do that. And one of the things we could do is say, let's just look at some of these exponents here. Let's take 10 raised to a number of different powers here. We'll go all the way out to, for instance, I started with 2. We'll go out to 12. Okay, so now what we're going to do is we're going to take a look at what we can do is we've taken a simple number here, the base, and we're raising it to a cell reference here. So we can just grab this, and as we drag that across, it auto increments the cell reference. So the next cell is 10 to the 3rd, 10 to the 4th, 10 to the 5th, 10 to the 6th, 10 to the 7th. Okay? All right. Now I want to do this one more time. Reason why we're doing this is it ends up in our spreadsheets here. Let's say we also want to say the base. We want to name the base here. We're going to say the base is 10. Our base number is 10. It could be 1. It could be 3.6. It could be any kind of number here. The base is equal to this. We want to show 10 raised to these same indexes here, these same exponents, right? So we're going to take this cell reference and raise it to that cell reference. Okay, we hit enter. Okay, now if we drag this across, it's not going to work. Why didn't that work? Okay, so if you're handy with Excel, you'll realize that going back to our original equation here, when we drag the cell across, it auto-incremented. It's looking for the base right here when it's really back over here. So what we need to do in our original equation is grab the cell reference, use our F4 shortcut, and make that an absolute reference there. So now when we drag it across, it should work. What it did was it held the cell reference, it held D16 constant through all these. See how it's not incremented, it's still D15, D15. Each of these cells, we use the absolute reference to the cell. So this is just a reminder of some basic Excel behavior that you need to know to get into the spreadsheets. In finance, we have things that earn interest, or we have an investment that get variable and unpredictable sometimes future earnings. So when you put some money into a debt instrument like a savings account, you earn some simple interest on that. It's predictable every month. The size of the period is always the same. When you have an investment, the return rate basically goes up and down. Every month you might take a look at where your stock value is as an equity. Look at your stock value and compare it to what you paid for it. It may be more valuable or less valuable, but it's more irregular than the very fact that that's why we have savings accounts, that it's less risky. that money is put to work by the bank, and we have less risky investments they're putting it into, more predictable, and so they can give us a predictable rate. They tell it to us, and it only changes once in a while. Lately, it hasn't changed for a long time, and it's very, very low. So we're just headed into the finance area here a little bit. We're talking about something about interest rates, and let's move on to another window here. Let's pop open another window. Okay. So since we're talking about putting money into a savings account, the first thing we're going to talk about is this is kind of very, very entry level finance here. We're going to talk about the future value of some investment or deposit, if you will. Let's call it deposit for a savings account. Okay. All right. So how do we predict the future value, or we calculate the future value of something? Well, we start out with a present value. Okay, how much money are we going to put into this account? And then at the end of every period, we earn some more interest. Okay, so if we're talking about earning every month in a savings account, so this would be month 1, this would be another month here, would be month 2, month 3, month 4, month 5. Okay, we'll make it 6, half a year here. Okay, so that's the end of period 6, 5, 4, 3, 2, 1. Okay, so when you put your money in, this is times 0. This is when you put your money in. So this is our timeline right here, just a quick timeline we're showing here. This is the month number across the top. And we're measuring or depositing the interest that we earn on it at the end of the period. Okay, so how do we calculate that? All right, let's use some real numbers here. Let's say the present value, today's value, is $1,000. We drop it in today, which is squiggly line here, and it sits there for 30 days approximately, and then we get a hit. We got a deposit back into this, which reflects the interest rate that we're getting on it. So to make things simple, we're going to use our rate. Our annual rate is going to be 12%. Okay, this is basic finance, and per period, since we have periods, we have 12 of them. How many periods do we have per year? We need to be able to calculate how much interest we earn at the end of every month. So you just simply take the annual rate all the way out to 12, okay, 12th month here, and that's 12% annual. So we have to divide by 12 periods or 12 months here, and that equals 1%. Every month we get 1%, which is 0.01. Okay. So now we're using some real numbers. We're saying our present value here is what we put in there today. The reason why we're calling it present value is time has not affected this. Okay, we have gained nothing yet. This is time equals 0. Very beginning, we start out with 1,000. Okay, so it's the initial starting point. That's the present value. Okay, so how much money did we make by the end of the first month? We have $1,000, and if we multiply that, it's $1,000. And if we multiply that by 0.01, that equals $10. Okay? So the first thing we say is how much money did we make? We made $10. Then we ask how much money do we have? And it's going to be 1,000 plus 10. Okay, so that's how much money we're going to have at the end of the first month. Now if we look at this equation, how did we figure this out? When we want to look at the future value, so the future value of this at the end of the first month is $1,010. How do we calculate that? Well, if we look at what we have right now, we have these two numbers, and these two numbers are equal to 1 plus 1,000 times 0.01, like that, and that is equal to the future value at the end of the month 1. When we look at it this way, we can factor this out. We have 1,000 showing up in two different places, okay? So if we factor the 1,000 out of this, what will we get? We get 1,000 times the 1. There's 1 plus the interest rate. So now we're going to calculate what happens at the end of the second period there, okay? So we're going to start out with $1,010, and we're going to be able to make that month 1010 times another 0.01%, And we'll flip over to Excel here, and we'll calculate 1010 star 0.01. So the interest is going to be $10.10. That's how much interest we get on the second month. Because we have more money in there, this is beginning to show the compounding of why interest is so great when you're making money like this. You have it in a savings account. It starts compounding every month. The gain from the previous month is included into the factor here. So we add 1010 on here. So we're going to end up with 1020.10. That's after the second month, we're going to have this much money. But now let's look at what we actually did here. We actually took 1010 times 0.01 and we added in 1010 again to get this. Okay, so to get this, we took 1010 plus 1010 star 0.01 like that, and we came up with 1020 like this. Okay, so there we see the principal here times the interest rate. Well, what we can see here is that we actually have 1010 times 1 plus the interest rate again. Okay, so the interest rate was 0.01. Okay. Well, what is 1010? 1010 was our initial amount of money times 1 plus the interest rate. That's what 1010 is, and we're multiplying that again by 1 plus 0.01. And these, when we factor that, we're going to get 1,000 times 1 plus the interest rate squared. Okay, so what we're doing is we have an equation we see developing here. That's a plus sign. We see an equation that's developing here for how we calculate how much money we're going to have at any point in the future. Okay, so it's interesting that this factor including the interest rate, the exponent here relates to which term we're in. So we're in the second term and we're squaring here. So we can use that connection later on to calculate this at any time. So now that we've seen the second period, we can actually just now use that equation and jump to the last period. Let's see if I can copy. I'm not sure I can do this here. Let's grab this and see if I can create another sheet. Okay, so that was from month 2. What we're seeing there now is our principal times 1 plus the interest rate raised to the exponent, which is which term we're in. Okay, so this is still very basic finance. We should all have this. I'm just trying to remind people about this. And just to show something out here, if we want to know how much in the 12th month, so we have term 1 here, 2, 3, 4, 5, 6, out to the 12th period or term here, so that's 12. We can now use this equation to understand how to calculate what value we have out here at the 12th month. So that would just be our principal, our initial money that we put in there, times 1 plus 0.01 raised to the 12th. And let's go show how to do that in Excel. Let's come on over here. 1,000 times 1 plus 0.01. And we use the caret to use the exponent. We're going to use the exponent here, so we're going to raise it to the exponent, use the caret of 12, okay? And what we're going to do back here is just clean up the equation a little bit, put the equal sign there, and you want to use a lot of parens when you're doing this to make sure that the order of operations is clear what you want there. So what we really want to do is add first. We want to do the 1 plus 0.01, and then we want to raise it to the 12th, and then we want to multiply it by the 1,000. So I'm just showing you what you can use a lot of parens here to make sure you've got the right order of operations. Hit enter, and that number will be 1126, and we'll just format it a little bit there. So it's 1,126.83 cents. So if we come back over here, we just write that in. That's how you calculate any future value here, starting with your present value. So here, in these cases, you want to find a future value, you know your present value and you know your interest rate. Just remember that the way that the interest rate is stated is often for a year, and you have to figure out how many periods you have. In our case, we had 12, and in the problems in the book, sometimes we talk about quarters. Let's now move into calculating a present value based on the fact that we know some kind of payment in the future, which would be your future value. And the way we're going to relate this is by the original equation that we have here, where we have the future value is equal to this present value times 1 plus the period rate, and we want to know and the period that you're interested in, the value, so the future value of the 12th or the 16th or whatever period you're interested in. It's just your present value times 1 plus the period rate raised to the n. We're going to rearrange this equation. I'll go slowly so we can track here. Present value times 1 plus period rate to the n, but we're going to divide both sides by this term here. So we divide both sides by this. These cancel out. We end up, if we know the future value, these are future payments coming in. They may be estimates, okay? So the future value is equal, the present value is equal to the future value. We just rearrange this. And this is now what we're going to look at is how we value a future payment here, a future value into the present, and we're using a interest rate here or an inflation rate or discount rate here that we use for the rate. So we'll go to a new window. Come over to the new window. So now we're going to be working with that equation. We're going to go back over to the Excel. Let's go back to Excel here, and we're going to show that problem. We want to be able to look at something we have a little bit of familiarity with here. We're going to look at the problem. This is a sample problem from Chapter 3, Jacobs. And this comes from the question. This is actually part of the question that we have here. And this is the initial state, things that we know from up front that were given. Okay, I'm going to move this out of the way. Now I just took these and I entered them into Excel here. So what we can say is there's different sections of the base case that we're looking at. We'll break this down a little bit more. I'll put a little box around everything. So first we'll put a box around this. And we need to format that. And we are going to use no fill on it. Okay, so we should just see the outline. So we see this outline here. Okay, so the next part of this was our schedule. We had a number of different phases, and we want to look at the schedule. So there's the second part would be the schedule part. So I'm going to drop another box around that. We'll look at that as something separate. See that? Okay, so that's the second part. Third part would be just entering in the given information here. Put a box around that. That's our third part. This is just basically getting set up. We're putting in the information here. We've broken down. There's 4 phases of development. We call them phases because they start at different times and end at different times. And we've taken the associated costs for this and distributed across the periods that we need to account for these. The development period is Q1 through Q4. So we take the 5 million and divide it over the first 4 quarters. And each quarter is 1.25 million, 5 divided by 4. Okay, so we do the rest with all the numbers here, and we put them into the appropriate phase periods here. As you can see, we just keep tracking through, and we put in here our marketing support starts here. Marketing support is $250,000 a quarter. And finally, by Q2 of Y2, we've produced and we've also sold. We've produced 5,000 units and we've sold 5,000 units. Okay. Something quick here, I want to simplify this a little bit. We weren't given the quarterly cost of production. We weren't given the quarterly revenues that we were bringing in. We had to calculate these. Okay, so we were given information about how many units we were producing over a year, and we had to start allocating that you got to think about that, put them into the appropriate quarters here. One thing you can do really quickly here is I will hide some of these rows. You can actually just hide these things in Excel and make things look easy. Hide those. Now we're having directly, here's the phases, and then they're just hitting. They're just hidden. The couple of lines that we just hid here are still there. You can open them back up again, and as I mentioned, we just hid them. They're there. But we're looking at the major items here that relate directly to the phases that we have. Okay? So that's the third part of performing one of these exercises here, these base case exercises. And then I would say the next section is we're going to add up all our period cash flows. Put a box around just that row. All period cash flows means is it's a summation line here. So I'm going to colorize that. Put that in yellow, okay? This period cash flow just means every period, we're just adding up everything that we have in the column, and we're looking at the net cash flow. So some months we're going to have negative numbers in here. The first 3 months we have negative numbers, still have negative numbers the fourth quarter, and I apologize, I keep saying months, but I meant quarter here, all the way into the fifth quarter. The fifth quarter we're still negative. We're spend, it's all negative down here, and then by the sixth quarter, or the which is second quarter of the second year here, we make some sales that outweigh all of the spending that we've done just for that month. In that month we netted $1.75 million. It stays like that all the way out. Okay, nothing changes from here on out. Since nothing changes each month, it's just coming in at $1.75 million. Okay, that's the line that we want to pay attention to now. We'll come back here, but I first want to go off and take a look at this and understand how we do net present value. Okay, we know we're going to get down to this line where for every term or every quarter we're going to discount that future value, because we're sitting here at 0 time right at the beginning of Q1, and these payments are occurring sometime in the future. So we have to find a way to discount that, and we can do that for a number of reasons. One of them could be there's a very high inflation rate. You might want to figure out what the present value of one of these future cash flows is compared to or discounted for the inflation rate. And the other reason that you might want to do it is to compare it against another project that might bear a certain predicted interest rate every month. So we're going to go back. Now we have a string of future cash flows. And let's look at how that looks. We're going to draw a picture of it. We'll do it more in a picture form over here. So we have something here. We're calling them period cash flows. Okay, and we have 4 per year because we're using quarters. We'll draw 2 years, third year, fourth year. The last quarter is quarter 16. It's a total of 16 quarters. Okay. Now, the concept behind present value or net present value is this. We're going to look at each month or each period or each quarter. In our case, we're looking at quarters. We're going to look at all of these as individual deposits. So present value, we look at it as though there were 16 deposits up here. We're going to label them 1 through 16. All the way down to the present value of 16. Cash flow 1, cash flow 2, cash flow 3. So we're looking at these as individual deposit accounts. A deposit into a different account, the first deposit we put in there comes out after the first quarter. It's a very short account that we have there. We put the money in after first quarter, we take it out, and that was the first period cash flow. You treat the second cash flow as though it were a different account. We put some amount of money in there. It matures for 2 periods, and we take the money out. Take the money out there. Look at the third cash flow here. Third period is here. It's as if it matures for 2 periods, and then we take the money out. It's a string of these different kinds of accounts here, and each one is incrementally the next period. We go all the way out to 16. Okay, so we go back to our equation here of our future value. We calculated that the present value is equal to any future value. So the present value of any period is of I, that's I, is the future value of that period divided by 1 plus the rate, period rate there, raised to the I. Okay? So we just explained how this works, or really just it's the difference between putting money into an interest-bearing account and then calculating the future value versus knowing what a future value is and regressing back to t equals 0, time equals 0 right now. Okay, so we're going to end up doing these calculations. We're going to do 16 calculations here. That's where the NPV, total NPV for a string of payments like this comes from. The string of payments, we just simply take this part of it and we just put this function in front of it. We just say that we're going to sum from I equals 1 to 16 all of this here. Future value of I over 1 plus period rate to the I. Doing this in loop. For every I, we're going to make the calculation. Come back to the Excel sheet. These are our unadjusted cash flows. So we need to adjust them. I created another sheet here. Let's take it offline a little bit so we can just focus on these quarterly cash flows that we have. So we have 16 of these cash flows as we just described by the pictorial there, and we have to make a calculation for each one. Right? Now, you have to track me here on this because we're going to have a discussion later on. The first period is a little bit different. The way that these cash flows are interpreted is that we put in $1.25 million at day equals 0. We put another $1.25 million in at day equals 90, 91. Okay? At the end of the first period, the beginning of the second period, we had to make another payment. Because no time went by for this first payment at time equals 0, there's no time effect on this. There's no effect of an interest rate working on it. So the first period is actually the adjusted. There's nothing to adjust here, so it's just simply the value, the cash flow from that period. The first term here that we have to take into consideration, this is the first number that has the time value of money working on it. It was there for a period. So we have to use our equation. We come back here. We look at our equation over here. So the future value of that first element divided by 1 plus the rate to the first, which is just 1 plus the rate. So how we do this, let's watch how we do this in Excel. We're going to take our number here. We need to divide by 1 plus the rate. We're going to use 8% in this example. So 1 plus the rate is 1.02. The periodic rate, or the period rate, is 1.02. And we need to raise that to the first power. We've already shown that Excel works with something raised to the first just fine. So we just put that in there. And we notice that this is a less negative number. And that makes sense. This says that if we put in $1.2 million into an account, 1.225490, that it would grow to 1.25 after a single period. That's the effective time value of money of one period with the interest rate. It increased by 0.02 or 2%. That's all that means. Likewise, what we could do is just drag this function over next door here. Okay, and as we drag it next door, we just need to bump the exponent here because now this is the second term. And if you notice, I've put indices up here above everything. These are the exponents. For this quarter, we're going to use 1.02 raised to the second. We calculate that. We just let that one fly. We put it in there. Now, how does this make sense? This says that if we had one account, we put in 1.22. After one period of interest working on it, we'd have 1.25. This says that if we put $1.201 million into an account and it sat there for 2 periods, we'd have 1.25. That's the logic. That's the thinking that we have here. Now, I'm going to show you some Excel here. We want to get a little bit more automagic with this, or we want to be able to speed up our process here and not hard code the exponent in these things. And the reason is we're going to do a sensitivity analysis. Later on, we're going to want to change the interest rate and see what happens. The next step here is let's make a more beautiful Excel function here to calculate the discounted cash flow for the 4th period. When we hard code it in, it would be raised to the 3. I laid out these indices here. So instead of just hard coding 3 in here, at least we can use a reference up here. So instead of hard coding 3 in here, we're going to do a cell reference of 3. See, we're going to pick up G4 here, and it contains 3. We hit enter, and that's our solution. Okay, so that's the first thing. So what we could do is now we could grab that and drag it across, and we've discounted every cash flow into the future using our equation. For each period, we're raising the interest rate here in the denominator by a larger and larger number, which is the period that it represents. Okay. Let's do something a little bit even more generic here so that we can see the effect of changing interest rate on it. So in our example, we were using an interest rate of 0.08 or 8%, and what we can do is we can just simply format the cell immediately as a percentage, and then we can type in here 8%. Okay, so it's going to show 8%. It's formatted as 8%, but it will be representing 0.08. Okay, the quarterly rate, or the periodic rate here, is going to equal that rate over 4. So we're going to make a calculation here. Okay, so this is our interest rate, and this is rate of the period. So we can do something else. Let's take care of cleaning up. There was a few of these initial boxes here that we have to go back to where we hard-coded things. Here's the first, or the last one that we hard-coded. So we can take that function and we can drag it across and we can drop it in. Notice something interesting here, that the 0th exponent, 0, actually worked. We raised 1.02 to 0, and we know when we raise anything to 1, it's 1, and it came out the same number. Okay, so that's just a little hint that you can use the index 0 for your first term. Okay, so we can total up the unadjusted line here. So this is going to be equals to the sum of all the unadjusted cash flows, which is $12 million. When we want to do the net present value, we add up all of these adjusted cash flows. Again, going back to our pictorial here, these are all these adjusted present values. Okay, so the cash flows were adjusted or regressed back to time equals 0, and we found out for each one of those cash outflows that we took a payment out, that how much money we would have to put into an account and have it bear versus the interest out to that period and get to that cash flow. So now all we need to do is do the same thing. We can just sum this line up, or just borrow the equation from the cell above it. So we're just going to borrow the equation, and it comes out to say that when we adjust it for an interest rate of 8%, that today's value of this project is $8.87 million. Okay, I'll format these as dollars so it's more obvious to us here. Okay, so that puts commas in there and the cents, and we can see that one way or another, there's different ways of using this time value of money. The mechanics are precisely the same, but it's how you interpret it. And one way to say is if we have 8% inflation, that instead of having the total value be 12 million, gradually inflation is eroding more and more away from each of the future payments. And in today's dollars, unless we do something, it's only worth $8.87 million today. And that's the effect of inflation on such a project as this, is that if you don't take it into account, the numbers aren't the numbers. The 12 million isn't going to have the buying power in the future. Your total buying power is going to be $8.87 million, not $12 million. Okay? We're using our initial conditions that we want to bake into our functions, our cell functions down here, so we can just change the rate up here and see the effect on this. Go into the first cell here, that's working just fine, and this 1.02 represents the interest rate. What we're going to do is remove this hard-coded 0.02, add in this cell value in here. Now, we need another set of parens in here, so be very careful when you're doing this so that you don't lose the correct order of operation, and the best way to do that is always contain the smallest part of what you're calculating into a parens. Enter, it calculated again, nothing changed, so that's working. And we can drag that right across, and we update all those cells. Now they all reference the header information up there. So the reason that didn't work, you can see that when we come out here at the end, the numbers are all the same. Something happened here, and we have to remember that we have to use an absolute value here. So we're going for an absolute cell reference here. We use an F4 to just change that to an absolute cell reference. And now when we drag it across, everything will be okay. Okay, so that should be the previous numbers that we hard calculated are now using a more generic form, and we can come in here and we can change this to 10%. Watch the numbers down here. If we change the percentage that we're gauging against in our project, I put 10 in there, and you can see those numbers all flipped. They all changed. So now we've worked out a very good worksheet for ourselves where we can demonstrate we have some unadjusted cash flows here that go into the future. We have this thing, this percentage rate I want to talk about. It's very important to what's going on in the problem. And when we make these adjustments, when we take care of adjusting for the time value of money, we end up with the values here. If we take a look, we want to prove to ourselves that we just reproduced what we had in the larger spreadsheet here. So I'm going to copy the same adjustments that we made here to our worksheet. I'm going to deposit them right here. We need to paste special. We just want the values. We'll push in the values, and you can see that we replicated exactly what was going on in the larger spreadsheet there. So we calculated at 10% the future cash flows. We regress them back to the current time, and the further out that we go, if you notice that in this time span, these periods out here, we're essentially taking in the same cash flow every month, but for every month when we apply the discount rate, in today's dollars it's worth less and less because of the time value of money. So it's the same dollar value for all these periods, but as it gets discounted more and more, it becomes less and less. In today's dollars, it would be worth 1.2 million about here by the 16th quarter here. Okay. So what does this percentage rate really mean? There's a few different interpretations that you want to use here. That it's the same mechanics, but it has a different interpretation. Let's go over and grab ourselves a clean sheet and write this up here. There's three different reasons that you might be doing this discount. The first one is inflation. Okay, we talked about inflation probably enough that it erodes the value of money. Basically has to do with new currency entering the market and driving prices up, and so the prices that we see at the market start going up, and if we don't have a raise, if we don't get a pay raise, then these things are more expensive to us. That's basically inflation. Okay, and when we come back and we take a look at the numbers here, it just means that you better keep in mind that if there's heavy inflation at like 10% a year, when we put in the 10%, that the true value of this in today's dollars is only 8.2 million, not 12 million, unless you do something about that. Unless you make inflation adjustments in the future and you talk to your customer and you say, make your payments larger here. We're going to need a cost of inflation adjustment here. The second reason that you might do this is that there is an opportunity to you want to compare it to a safe investment. Okay, so a safe investment You might be able to put this into a savings account, which is very safe, okay? And if you could put it in there at 10%, what we're showing here, when we show this number, the word net is very important, okay? So the word net here means this is basically your profit margin or your profits from this whole operation. This is what you're going to make, okay? If you remember, we actually removed all of our negative cash flow here. We've taken all the payments out of this, and we've looked at what the income, the revenues have been, and we subtracted out the expenditures that we were paying out, and we subtract the expenditures from the revenue we have, and this is what's left over. So we've got to go back to this as the feeling, the approach that this is really what we're talking about is profit, not revenue. Okay, so this is not revenue. This is profit here. What this tells us is this is how much our project makes above an account that you put the same amount of money in that matures. We're making $8.2 million more than a simple deposit account that's bearing 10%. That's the difference right there. What happens if our net present value is equal to 0? If the net present value is equal to 0, that means that we're earning in our project exactly 10%, because that's the number we use. We use our comparable value here of 10%. Our reference number here is 10% discount rate. Okay, so it says that we were able to manage no extra margin here above a simple 10% account that we could put it in that was much safer. We got all involved. We spent all kinds of millions of dollars here, all kinds of activity. People got paid, things got bought, things got made and sold. And after all that work, we could have just sat back and we could have put it into a savings account. That's what one of the interpretations of this means. But according to the numbers that we have here, we earned 8.2 million above putting it into an account at 10%. That's basically a couple interpretations of why you might do this. The third reason, outside of inflation, so we've named two different ways to interpret the rate that we use. The first reason, or the first interpretation, is inflation. The second interpretation is that let's compare it to a safe investment, and at the same time, very similar to comparing it to another opportunity here, it was as if we have this project 1 we just did all the calculation for, and there's a project 2, and there's a way of calculating for another project that what an average, or what we call the internal rate of return, is on another project, and we can say we've calculated that internal rate of return on another project to be 10%. It's kind of like putting it into a different investment than a deposit account. And what we've tried to prove is how many dollars in excess of 10% did we come out with, and at 10% it came out to $8.2 million. Those are the three interpretations of that. Well, we're on our last step here. We've calculated all these things by hand, and it's sufficient. We're all ready. This number, if you submitted it into Connect or submitted it as homework, it was pretty close, then you have full credit on it. However, we do always want to improve our Excel skills, and there's a net present value calculation in Excel, and I want to show you how to use that. The first thing I want to talk about before we use it, there's a special case. We have to handle your cash flows, a very special case. First of all, the net present value function works on your unadjusted numbers, okay? So we've solved it once. This is solution 1, if you will, okay? Solution 1 is we basically hand-carved the solution here. For every term, we accounted for the time value of money for that period. Each time calendar term or period here, we discounted it increasingly as we went out into the future, as we're supposed to do, and we came up with a totally valid answer. We used definitions along the way of present value and adjusting for the time value of money, and the numbers all come out, and that's the legitimate number. But we did it the longhand way. If anything, we looked how to use some cell references here to clean up the functions within each of these cells. And so we did it incrementally. So now when we look at what the function is in here, the formula, Excel formula, even though it looks a little bit cryptic, we do know how we built this. Bit by bit, we built up that function, or the formula there. The way that the net present value Excel formula works, it wants the first period's cash flow where time has had a chance to do its work with an interest rate or a discount rate or an inflation rate. And if we look at the definition of the problem, it said that what we're going to do is in the first actual quarter, when we drop 1.25 million into development costs, it's at day 0. So this number went in at day 0, and that's what we put in. We didn't put anything more in over the next 90 days of the quarter. And at the end of that first quarter, we put in 1.25 million. So this is the first term that we are concerned about discounting, okay? And I'm defining it this way because the Excel function, what we're going to do is we'll put it over here, okay? So this is the Excel solution to this. Over here, we're going to put in the NPV value formula. We take NPV. The first thing that it wants here is a rate, and we're going to use the quarterly rate, not the annual rate. You want to go by what period you're using. I mean, we're using quarters. If you were doing months, you would put in a rate, your annual rate over 12. Okay, just to be clear about that. So we're going to drop in our rate. That's 0.025 right there, but we're using the cell reference. Okay, and then it wants these strings of values. The first value is the first cash flow out in the future. The first cash flow out in the future would be this one. These are the adjusted ones we hand adjusted by hand. These are the first cash flows that we hand adjusted. These are the raw unadjusted cash flows here. So the net present value function works on the unadjusted ones, but it wants to start with the first value that is affected by this time value of money, which would be second quarter. We grab all the values here, and we close out with a paren, and we hit enter. Now, we see that these two numbers are different. Well, what we have to do, by the way that the NPV is defined in Excel, we have to add in the first term here, the first term. So all we have to do is adjust that. Unfortunately, you have to do a mechanical adjustment here, and this would be equal to that number plus whatever the cash flow was in the first quarter. We hit enter, and look right to the penny, we're right on there. Okay, so that's how the NPV function works. Again, you have to understand, sometimes a project will say that you took an entire 90 days to get your act together, and then you made your first payment at the end of the 90 days. It's a very fine line. You have to watch yourself on this and just understand how the NPV works and whether you need to do what we just did here and pick up the actual second quarter, because the whole project started on day 0. We dropped our first 1.25 million and we wrote a bunch of checks that first day, and waited another 30 days and then dropped another 1.25 million in. So that's the last part of the problem, and that's just how to use the NPV for Excel. Hope you hang on there. It looks like this video is going to come out just about the length of a regular class period, which I was aiming for. And so hopefully this is very helpful, and you can go back to this and hit rewind and get back to the beginning or other parts of this that you have to review.